Today's lesson is a continuation of the concept of the rules, or different rules for exponents. And what we're going to cover today is what's called the power to a power property. So let's take a look at the exploration. A marine club um, has purchased an aquarium. The aquarium is the shape of a cube, with each side of the cube being 2 to the 4th power inches long. Okay. The volume of a cube is obviously the side cubed. And what I want to first have you do is write a multiplication expression to represent the volume of the aquarium. Well, one side is 2 to the 4th, the other side is 2 to the 4th, and the third side is 2 to the 4th. Now, we learned yesterday that when we do this, we add the exponents, so this can be simplified to 2 to the 12th power. Now, let's write this in exponential form. Well, what we're really doing is 2 to the 4th power being raised to the 3rd power. And what do you notice? Well, these are all equivalent statements. Okay? So what did we actually do to get 2 to the 12th power as opposed to writing this all out? Well, you can see that there was a multiplication of the exponents in number 3 to get answer 2. And that is really what our power to a power property tells us. What our power to a power property tells us is that if I have a base raised to multiple powers, that I simply multiply those powers to get the single exponent. And we say to raise a power to a power, multiply the exponents. Okay? So let's go through a few examples of this. These are the more straightforward ones. So 7 squared cubed, 7 to the 6th, x to the 5th to the 4th, x to the 20th. Okay? And just to demonstrate, anything cubed means times itself 3 times. And as you learned yesterday, that gives us our 7 to the 6th power. Now, Julia said that 3 cubed squared is 3 to the 5th. Is she correct? No. She added instead of multiplied the exponents. Okay. Now, let's expand this or apply this in a couple of different situations. Let's say I have 3a squared to the 4th power. So now I have 2 separate bases here, 3 and a squared. Well, raising something to the 4th power means to multiply it by itself 4 times. And now if I were to do this math, you learned yesterday we can multiply the 4 3's to get 81, add the exponents of the a to get a to the 8th. What the power to a power rule is doing is it's just shortcutting for us the rule we learned yesterday with the multiplication or division. And so what we're actually doing is we're actually distributing this exponent of 4 to both bases. So if I have ab to the m power, that means a to the m and b to the m. If I have a divided by b to the m power, a to the m divided by b to the m. Okay? Remember that we're still within the order of operations because I have multiplication and division in here mixed in with exponents, and that's not violating my order of operations. So the explanation is if more than one base is being raised to a power, then distribute the exponent to each base. Now, let's go through some examples, and then we're going to talk about where we have to be careful with this rule. All right? So I have 3y to the 4th cubed. Hopefully you'll see that that is 3 cubed y to the 12th, which is 27y to the 12th. Negative 4 cubed, negative 4x to the 5th cubed. Well, I'm just showing you that this means negative 4, since it's inside parentheses cubed, x to the 5th cubed. Negative 4 cubed is negative 64 x to the 15th. Remember what we talked about yesterday, that you have to be careful there. The next one, this is telling us, and another way to look at it, if this helps you to understand whether it's going to be a positive or negative, this is telling me to multiply a negative number 3 times. A negative number 3 times is going to be a negative answer. Here, I'm multiplying a negative number 4 times, so you should be expecting a positive answer. So this is the same thing as, and you don't have to write all of this out. I'm just trying to highlight how this rule works. That's a 4 there, sorry. So negative 3 to the 4th is 81. X to the 4th, y to the 20th. And then lastly, this is going to be 8, a to the 12th, b to the 18th. Okay? All right? Multiple choice. Which expression, and my alignment's a little off, so apologize, sorry about that. Which expression is equivalent to 3x to the 4th squared? Hopefully you realize that that's D. Rewrite 5 times 8 to the 12th power as a product of each base. It's 5 to the 12th times 8 to the 12th. Now, let's make sure we understand this. Does 2 plus 3 cubed, in parentheses, equal 2 cubed plus 3 cubed? Now, you can test this out by doing the math, okay? But if you think about it, the left side is written in a way that tells you under of order operations to add first and then apply the exponent. The right side is telling you to do the exponent and then add. So let's just do the math. This would tell me to do 5 and then cube it. This would tell me to cube 2 and cube 3. And you'll see that you get 125 on that side and 35 on the other. And that does not work. And so the rule there is no, you do not distribute the exponent if the values inside the parentheses are being added / subtracted. It violates the order of operations. Okay, so our 4th and 5th rules today dealt with the concept of power to a power. Tomorrow we will move on to our last set of rules dealing with the laws of exponents.